Well, hello and welcome back. We're going to tackle the rest of our trig derivatives and a little bit more with our chain rule. So let's get started. Well, folks, I know you've been dying for this day, the rest of the trig derivatives. So here they are. There's 6 that we're going to need to know by tomorrow. So feel free to make some flashcards for yourself, do what you need to do to get these memorized. We should know the derivatives of sine and cosine by now, and we'll kind of work our way through the rest of them. So I do have a few tricks for you. One thing you'll notice is if your function starts with a c, its derivative is a negative. For example, the derivative of cosecant starts with a negative. The derivative of cotangent starts with a negative. The derivative of cosine starts with a negative. If it starts with a c, its derivative is negative. Those are the only negative ones. The other two, I tried to remember them in pairs. You know, sine was cosine, cosine is negative sine. Hopefully those are pretty straightforward. Tangent is secant squared, and cotangent is negative cosecant squared. Basically, I say to myself that tangent and cotangent have one term squared. And again, I'm just trying to make up goofy things to help you remember them. They both have one term squared. The other thing I say is cotangent starts with cosecant. Those have the cos, so to speak. Cotangent goes with cosecant. The secant is secant x tan x, and the cosecant is negative cosecant cotan. Now you'll notice they both have 2 pieces to them, and they both start with what they are. Secant is secant tan. Cosecant is negative cosecant cotangent. Again, the cos are together. These are both the co ones. So again, do what you need to do. Make up what you need to help yourself remember those, but we have to know those by today. All right, number 1. This is read the secant of 10x. So when I say of, I'm putting my parentheses in there. So now it's clear that I have a chain rule. I have an inside and an outside. So remember, I'm going derivative of the outside, keep the inside. Okay, so the derivative of secant is secant. Now you want to say x, I know you do, secant x tan x. But remember, it's secant, keep the inside. Tangent, keep the inside. Times the derivative of the inside. The derivative of 10x, of course, is just 10. So I would pull this out as 10, secant 10x, tangent 10x. Lots of self-talk. Remember, keep the inside. All right, number 2, cosecant of 5x. Pause it, try it on your own, see if we get the same thing. Watch that bear trap. So our first bear trap of the year is really paying attention to what that inside is. So the derivative of cosecant is cosecant cotangent. So I'm saying it starts with a c, so it's negative. There's my first bear trap. Cosecant, keep the inside. Cotangent, keep the inside, times the derivative of the inside. And again, I would just pull that out as negative 5. Cosecant 5x, cotangent 5x. Number 3. So again, read it out loud. F of x equals x cubed times tangent of 4x. So I'm breaking it up where I said times, and watch my of as well. I'm going to wrap that bear in parentheses. Okay, so pay close attention. I have product rule, and this guy is a chain rule because it has an inside and outside. So again, lots of self-talk. First, derivative of the second, I'm going to leave it blank for a moment, plus the second derivative of the first. So I'm just going to rewrite my second term down, the tangent of 4x. Okay, so there's my chain, my inside and outside. Derivative of the outside, so the derivative of tangent is secant squared, keep the inside, times the derivative of the inside. So that's what I'm going to put up here. I'm going to go 4 secant squared of 4x. The derivative of x cubed, that second or that first term there, of course, is just 3x squared. If I have any GCFs, I'll pull them out, which I don't think I do, so I'm just going to rewrite. I can multiply the 4 and x cubed there, so I'm going to say f prime of x equals 4x cubed secant squared of 4x plus, pull that out front, 3x squared tangent of 4x. Number 4. Again, I want to try this two ways. One where we use quotient rule, one where we go product rule. All right, so let's start with quotient rule. Low d high minus high d low over low squared. Why don't you pause it, see if you get the same setup. So I've got my low d high minus high, the d low was just 1 over low squared. And lastly, to clean that up, I'm just going to pull out. You make sure you pull that negative out there. So I'm going to say that's negative x cosecant squared x minus cotangent x all over x squared. Now let's talk about our canceling. I can't cancel this 1x with this x squared because this is being subtracted here. You only cancel when you're multiplying. So if this was pulled out as a GCF, that would be different. But because it's not in every term, I can't cancel. And that's my final answer. Let's try that same thing with product rule. The first thing I would do is rewrite that function and say g of x is actually cotangent x times x raised to the negative 1 power. Alright, so I'm going to say it's g prime of x is the first cotangent x times the derivative of the second, negative x to the negative 2, plus the second times the derivative of the first, cosecant squared x. Now I just got to clean that puppy up. So I'm going to say, I can pull out, notice my GCF again. I have an x to a negative power in common. I'm going to pull out the smallest, so I'm going to pull out an x to the negative 2, that's the smallest, and I'm left with a negative cotangent x, if I take that out. Remember, you subtract exponents. I take the negative one I have, and I subtract negative 2, which leaves me with a 1. So I'm going to have a plus x times cosecant squared x. And then lastly, I can move this x squared to the bottom, because it's a GCF out front, and I get exactly the same thing I had with quotient rule. Remember, pause, rewind, do what you need to do to make sure we get those down today. Next example. Remember, it's all about the rewrite. 2 is a coefficient, so keep that in mind. So let's rewrite this. I would say that is 2, it's cosecant of 3x, and the cosecant's the one that has the 5th power on it, so I'm going to say it's that junk to the 5th. So again, here's my chain. I have this inside, I have this outside, and I have the double chain because I have another inside here. Alright, so let's say y prime equals, derivative of the outside is the power rule, bring that power down, 5 times 2 is 10, leave the inside, all raised to the 4th. Now if you have to, rewrite your inside. Cosecant of 3x. Now we're taking its derivative. The derivative of cosecant is negative. It starts with a c. Cosecant, keep the inside. Cotangent, keep the inside. Times the derivative of the inside, which is 3. Alright, watch that bear trap. That's one we got to watch for. Keep the inside. Lastly, I'm just going to clean this puppy up. So I can leave, let's leave that as 10 cosecant of 3x. I can say this negative, to the 4th. Then I have a minus, I can say that's 3 what am I writing? Cosecant of 3x, cotangent of 3x. And there you have it. If I wanted, I could pull out, let me fix that cosecant there. I could pull out a cosecant of 3x to the 1st. That's the smallest one if I wanted out front. Alright, just a couple more to practice with here. Again, I'm going to rewrite my function f of t. I'm saying that's negative 5t times the secant of 2t. Alright, and notice this is a function with a t in it times this function with a t in it. So that's product rule. Plus, I've got 2, the tangent of, now here's another little bear trap, guys. Be careful here. This tangent is not of t minus 3. It's only the tangent of t, and it's that junk cubed. And then there's a minus 3 on the end. And how do I know that? Well, if they wanted t minus 3, they'd have to put it in parentheses. Otherwise, it's exactly the term next to that function. Alright, so another bear trap to watch out for tonight. Now that I've got this function rewritten, I'm going to carefully take its derivative. Notice we said this was product rule here. So I'm saying it's the first times the derivative of the second. And this has an inside and an outside. So the derivative of secant is secant, keep the inside, tangent, keep the inside, times the derivative of the inside, plus the second term, times the derivative of the first. Okay, so that green just represents this first derivative here. I'll change markers for this one. This guy's derivative, I have my inside and my outside. So I'm going to say that's plus power rule, so 6, keep the inside, tangent of t, raised to the second. Now the derivative of tangent of t is just going to be, derivative of tangent is secant squared, keep the inside. And technically the derivative of t is 1, I don't need to put a minus 1 there, or times 1. And lastly I have this minus 3, the derivative of any constant is 0. So maybe pause it, try it again on your own there. And again, I'm just going to clean it up at this point. I can multiply the negative 5t in this 2. So I'm going to say I get negative 10t, secant of 2t, tangent of 2t. I'm going to pull this negative 5 out, so minus 5 secant of 2t. And then I get plus 6 tangent. Notice I'm going to put that squared back where it belongs, tangent squared t, and then secant squared t. Whew. Now again, if there's a GCF, you could pull it out, but I think at this point we're good. I don't think we do actually have a GCF between all three terms here. So nice job. Alright, next example, I've got a messy one for us. Find the equation of the tangent line and the normal line to the graph at this indicated point. So the second I see anything about lines, I'm saying I need a point and a slope. So the point is typically my nice algebra part. I know the x value is pi over 8. I just need to plug it in to get my y value. So I'm going to say that's the cosecant of 2 pi over 8 plus the cotangent of 2 pi over 8. Now, you might be thinking, crap, I don't know what the heck the difference of pi over 8 is. But remember, this reduces, and this is just pi over 4. Same thing here, pi over 4. So don't get too nervous, it should be something we know. So the cosecant of pi over 4, of course I don't have memorized, so I'm going to say, well, that's just the reciprocal of the sine of 45. The sine of 45 is radical 2 over 2, so I'm going to say this is 2 over radical 2. Now, I think if we rationalize that real quickly, it turns out to be something a little nicer. I get 2 radical 2 over 2, which of course is just radical 2. Cotangent of 45, I'm really going to think tangent of 45, which is 1. The reciprocal of 1 is 1. So I get a lovely y value of radical 2 plus 1. Now the fun part. Now I need to get the slope. And remember, that's my calculus. That's all I'm going to do is take its derivative. But read it out loud and put in parentheses where they need to be. This says the cosecant of 2x and the cotangent of 2x. So the second I say of, I've got myself an inside and an outside. So this derivative is going to be derivative of the outside. The derivative of cosecant starts with that c, so it's negative cosecant cotangent, but cosecant keep the inside, cotangent keep the inside, times the derivative of the inside, plus the derivative of cotangent, again starts with the c, so negative, tangents are the squareds, cosecant squared, keep the inside, times the derivative of the inside. Lots and lots of self-taught, guys. Now at this point, I'm not going to bother cleaning it up because I'm just going to evaluate this function at pi over 8. So I'm going to get negative cosecant. That 2 pi over 8, of course, is pi over 4. Cotangent of 2 pi over 8, which again is pi over 4. All of that times 2, plus I get negative cosecant squared of 2 pi over 8, or pi over 4, times 2. So I do have to slow down and really think this through. When I see pi over 4, I'm thinking 45. The sine of 45 is radical 2 over 2, so I'm going to say negative 2 over radical 2 times cotangent of 45 is 1. If I flip that, I still get 1. times 2 plus the cosecant of 45. So that's the sine of 45 was radical 2 over 2. Flip it, that's 2 over radical 2. But notice it's cosecant squared. And there's a negative there, so I'm going to change this plus to a negative. And all of that times 2. Alright, so when I multiply, remember, you multiply the tops together and you multiply the bottoms. So I'm going to say this is negative 4 over radical 2 minus, when I square this, I'm going to get 4 over 2. So I'm going to get 2 times 2, which is 4. Now, if you want to use that for your slope, that's perfectly fine. You don't have to clean things up. I'm just assuming that's not what the multiple choice is going to be. So I'm just going to practice cleaning it up. I would say this is negative 4, and if I rationalize that, radical 2 over 2 minus 4, which of course is negative 2 radical 2 minus 4. Now, I'll just throw all of that in the equation of my tangent line and my normal line. And remember, the only thing that's changing in the tangent line and the normal line would be my slope. My y value, shucks, I forgot what it was. I think it was radical 2 plus 1. And notice I'm putting that in parentheses. Okay, otherwise I have to distribute that negative. My slope is negative 2 radical 2 minus 4. And I'm times x minus pi over 8. And if I'm the tangent, the normal one, I'm going to be negative 1 over negative 2 radical 2 minus 4 times the x minus pi over 8. Well, I think that's enough practice for tonight. Take your time and feel free to rewind and replay anything you need to. And we'll see you tomorrow. Have a great night.